This is Pre-Calculus B, Unit 3, Lesson 3. Double angle formulas is the title. It actually refers to three sets of identities. That's double angle formulas, half angle formulas, and power reducing formulas. They're all the same class of formulas. So let me remind you of some formulas that we already know. Sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Okay, let's extend that. What if I'm now talking about the sine of 2 alpha? Well, that's like the sine of alpha plus alpha, which is sine alpha cosine beta, cosine alpha, plus sine alpha cosine alpha, which simplifies to 2 sine alpha cosine alpha. Okay, so let me shorten that here. Sine of 2 alpha is 2 sine cosine. Okay, that's our first double angle identity. Okay, and likewise, we can do the same with cosine. Cosine alpha plus beta is cosine cosine minus sine sine. So cosine alpha cosine beta minus sine alpha sine beta. Okay, which is, if I change it now to cosine 2 alpha, think alpha plus alpha. It's cosine alpha minus sine alpha sine alpha. Okay, that simplifies to cosine alpha, cosine 2 alpha equals cosine squared alpha minus sine squared alpha. So the double angle formula for cosine is cosine squared minus sine squared. Okay. Now the double angle formula for tangent is not too hard either. You recall the tangent formula. Tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So if I change this to tangent of 2 alpha, that is tangent alpha plus tangent alpha over 1 minus tangent alpha tangent alpha. Simplifying that, tangent of 2 alpha is 2 tangent alphas over 1 minus tangent squared alpha. Okay, so this is the double angle formula for tangent. Okay, and it allows me to find the tangent or the sine or the cosine of twice whatever angle I want. So if I'm looking for an angle that's twice what I want, I can break it down. All right, and let's look now a little bit longer at this cosine formula. So those are 3 of our identities. But let's go back to the cosine formula, especially as it reveals some squareds there. So cosine 2 alpha is cosine squared minus sine squared. Okay, you remember the Pythagorean identity, which says sine squared plus cosine squared equals 1, which can be modified to say sine squared equals 1 minus cosine squared. Also, it could be modified to say cosine squared equals 1 minus sine squared. Okay, let's substitute here. Cosine 2 alpha then, 2 alpha. And let's replace sine squared with 1 minus cosine squared. So cosine squared minus 1 minus cosine squared. Minus 1 minus minus is plus. This is 2 cosine squared. Actually, let's do it this way. Cosine 2 alpha equals 2 cosine squared minus 1. Okay. Likewise, I can do the same thing substituting 1 minus sine squared for cosine squared. So cosine 2 alpha equals 1 minus sine squared minus sine squared. So cosine 2 alpha is 1 minus 2 sine squared alpha. So these are some more identities. We already had this one from the previous page, right? We have this one, and we have this one. So there are 3 different forms for the double angle formula for cosine. The first one is probably the most frequently used and should definitely be memorized. The second one is where we get the half angle formulas. So let's bring that down here. Okay. So half angle formulas. Let's rearrange things here. Cosine 2 alpha equals 2 cosine squared alpha minus 1. And I'm going to solve this for cosine alpha. So I'm going to add 1 to both sides. Cosine 2 alpha plus 1 equals 2 cosine squared. I'm going to divide 2. Cosine 2 alpha plus 1 divide 2 equals cosine squared. I'm going to reverse the order using the symmetric property and take the square root. Cosine alpha equals plus or minus, when we square root you get positive or negative, cosine 2 alpha, and I'm going to rearrange that a little bit, 1 plus cosine 2 alpha over 2. Okay. Now here's what I'm going to do. I'm going to say let's substitute. Let beta be 2 alpha. Then alpha is beta divided by 2. Right? It can be any letter you want. Right? So this becomes cosine beta divided by 2 equals plus or minus the square root 1 plus cosine 2 alpha is beta, so cosine beta over 2. And there is the first half angle identity. So if I have a half of something and want to increase it to bigger, I'm going to use the half angle identity. So for example, if I want to find the cosine of 15 degrees, which I'll do here in a minute, I would then use 15, and then cosine b would be 30. Cosine beta would be 30. Okay. Let's take this same formula, though, cosine 2 alpha equals 2 cosine squared alpha. Okay, actually, let's do the other form here, sine squared. Okay, sine squared. So cosine 2 alpha equals 1 minus 2 sine squared. And let's solve that for sine squared. So add 1, cosine 2 alpha, actually minus 1. And I just realized I probably should have left it cosine plus 1. I think that's the way it's written. Equals negative 2. No, actually, it won't be. 2 sine 2 alpha. And then divide by negative 2. And then I'm going to switch the order. 1 minus cosine 2 alpha divided by 2. negative divided by negative. And when you divide by a negative, you change the positive cosine 2 alpha to a negative and the negative 1 to a positive 1. Okay? And whoops, I messed up. 2 sine squared alpha. That's what I did. 2 sine squared alpha. Sine squared alpha. All right, sine squared alpha. Okay, now take the square root and reverse things around. Sine of alpha equals plus or minus square root 1 minus cosine 2 alpha over 2. Okay, and if I do the same beta substitution I did before, I get sine of beta over 2 equals plus or minus square root 1 minus cosine beta over 2. Now notice something here. Both half-angle formulas use cosine in the formula. The only difference being that for cosine it's 1 plus and for sine it's 1 minus. So those are good hooks to use. Okay. Now I do want to derive a tangent double angle formula, but I'm running out of time. I'm going to go ahead and do it, but that'll be the last thing I do on this recording. Okay, so let's move things over here, and let's derive a tangent formula. Okay, so we have sine tangent of, I'll use beta divided by 2, is sine beta over 2 over cosine beta over 2. Well, sine beta over 2 is the square root plus or minus the square root of 1 minus cosine beta over 2 over plus or minus square root 1 plus cosine beta over 2. Now square roots can be extended over each other, so this is a square root of both complex fractions. The 2's cancel, and we end up with the following identity. Tangent beta divided by 2 equals the plus or minus the square root of 1 minus cosine beta over 1 plus cosine beta. Okay, and there were a couple different forms given in the book as well. All right, now, yeah, and I'm going to go ahead and leave it at that. You end up with the power reducing formulas by taking the half angle formulas and squaring both sides. All right, and there's one more question on signs. What about the plus or minus? Well, in regard to the plus or minus, don't memorize when and where it's negative and when it's positive and all of that. Simply do this. Recognize what quadrant the angle is in and use the unit circle to help you out. Remember, in the first quadrant, sine is positive where it's up here, sine, and negative when it's down here. Okay, cosine is positive to the right and negative to the left. Tangent depends on sine and cosine. 2 positives are positive, 2 negatives are positive. A negative and a positive are negative, and so on. And then the reciprocals all have the same sign. So just remember the trig functions and where they are positive and where they are negative to know whether the answer is positive or negative. Okay, I better leave it alone, and I'll get to solving specific examples in the next video.